Okay, so page 6, the remainder theorem says when a polynomial function p of x is divided by x minus c, where c is any number, then the remainder can be written as p of c. So that's telling you if you plug c in, remember you have to use the root, right? So zero product property would give me c for the root. If I plug that into the polynomial, whatever the answer is that I get, that's going to be the remainder. So when a polynomial function p of x is divided by x minus c, where c is any number, and the remainder can be written as p of c, if the remainder is 0, then we know it is a factor of p of x. So example 2, is n minus 6 a factor of that polynomial? That is, does p of 6 equal 0? So we get to plug 6 in. Remember I did zero product property with my factor. 6 squared minus 47 times 6 plus 6 cubed plus 30. These are kind of big. Take my word for it. If I carefully did the math, I would get an answer of 0. Since p of 6 equals 0, 6 is a root, and x, well, it was using n, so n minus 6 is a factor, because the remainder was 0. So for all of these, we've been giving you a root or a factor ahead of time, and then you've been doing your long division to figure out what's left over. Well, the fundamental theorem of algebra helps us if we don't give you a root or a 0 ahead of time. So you can read through the fundamental theorem for yourself, but basically I want to highlight the rational root theorem down below. So let's go straight to the example. We call this P over Q a lot. P over Q, where P is the factors of the constant term. So in our example, that's 6. And Q are the factors of the leading coefficient. So in our example here, that's 2. So you list out everything that divides into 6. 1, 2, 3, and 6 are all divisible into 6, plus and minus. And then everything that divides into 2, plus and minus, 1 and 2. And then you do every possible combination of the yellow over the pink. So we did 1 over 1, 1 over 2. Sorry, they didn't list them in the same order I would have. But you do every possible combination of... Oh, so they did the denominators first. Anyways, every possible combination of your factors of 6 over your factors of 2. P over Q. Constant over leading coefficient. So there's an example on the next page. So I just want the possible roots. So if it's not possible, we wouldn't do division with it, right? Because we'd be wasting our time. So our P over Q is always plus and minus. I just write the plus minus once. And it's going to be factors, numbers that divide into 12, over factors, numbers that divide into, there's an imaginary 1 at the front, right? So we're going to have plus or minus. Factors of 12. 1, 2, 3, 4, 6, and 12. Make sure you understand those are all numbers that divide into 12 evenly. And then factors of 1 happen to just be 1. So the possible ones would be, I just write the plus minus once. 1, 2, 3, 4, 6, and 12, because they're all over 1. But remember also, negative 1, negative 2, negative 3, negative 4, negative 6, and negative 12 would be possibilities. So we don't have 6 possibilities, we have 12 possibilities. To find out if it actually is a root, you could try it. Find P of 1 and see if you get an answer of 0 or not. If you get an answer of 0, it is a root. So would we try 7? No, 7 would be a waste of time because it's not in our possible roots. So we find our possible roots to see what we're going to do division with to find out if it actually is a root. So down below, we're going to calculate all the roots for that example. So we're done with that one at the top. Write out your possible. Pause the video. Write out the possible roots for this polynomial. Okay, so hopefully you had factors of 6, plus and minus, over factors of 2. Then the possible ones, I don't want to take up too much space, so I'm just going to go over here. The possible ones are going to be plus and minus 1 over every denominator, 1 over 1, 1 over 2. 2 over every denominator, 2 over 1. 2 over 2 is just 1 again, so I'm not going to list that one. 3 over every denominator, 3 over 1, 3 over 2. 6 over every denominator, 6 over 1. 6 over 2 is just 3 again, so that's the end of my list. So how many are there? So there's 6 of them, but don't forget the negatives. So plus and minus all of those. So you have 12 possibilities. So we obviously don't want to try 5. I don't want to try 4. I only want to try numbers on this list. And the easiest way to do it is to do p of something. So I don't know, it would be up to you, but let's just try p of 1 and see if that works. Plug 1 into the polynomial and see what you get. Okay, so I plugged in 1, and I got to the point where I knew the answer was not going to be 0, so I just stopped. Don't forget, though, negative 1 might work, and most often students forget to try the negative answers. So now plug in negative 1 and see what you get. Okay, so if you carefully do the math, when you plug in negative 1, you'll see that you get an answer of 0. Remember, that's your remainder, so that means negative 1 is a root. Well, now that you have a root, you should know the factor. So remember, it's zero product property, right? So if negative 1 is a root, opposite, x plus 1 is a factor. And now you're going to do your long division with x plus 1. Okay, so we have x plus 1. This is supposed to work. And we're dividing into that polynomial at the top, right? So it starts with 2x to the 4th. So in order to get 2x to the 4th, I need to multiply by 2x cubed times 1. My x cubed coefficient is just positive 1. So I need to have negative x cubed. To get that, I need to multiply by negative x squared times 1. My x squared is negative 14, so negative 13x squared. Negative 13x, negative 13x. I need to get negative 19, so negative 6x minus 6 minus 6. That matches the last coefficient, so we know we did it right. And we've gotten it down a little bit smaller. So now I have this polynomial that I want to do the exact same thing with. So on the next page, I'm going to copy down that polynomial, and what I've gotten so far is my answer. Okay, so I took the original question, I wrote that on the top. We figured out that x plus 1 is a factor, and when we divided, we got that TL answer, 2x cubed minus x squared minus 13x minus 6. Now we need to take that answer and find our possible p over q's. So sometimes they change, right? So you want to check each time. This one happens to still be a 6 and still be a 2. So list out your possibilities, plus or minus, factors of 6 over factors of 2, plus or minus 1 over 1, 1 over 2, 2 over 1, 2 over 2 is a repeat, 3 over 1, 3 over 2, 6 over 1, and 6 over 2 is a repeat. But remember, on this page, we already tried positive 1, so positive 1 does not work, but it is possible that negative 1 will work again. So now you want to try another one. I'm just going to suggest that you try p of negative 2, just to save us time. But in theory, you might have to try all of those. Always try the whole numbers first. Chances are there's going to be a whole number that works. So why don't you try p of negative 2? Pause your video. Just as a heads up, you're plugging it into the new green equation. So it's a smaller equation. We want to make this smaller every time. Okay, so hopefully you got that negative 2 worked. Remember, if negative 2 is a root, then opposite of zero product property, x plus 2 is a factor. So now I know when I want to divide into that polynomial. We're going to do long division. We're looking at the teal colored equation. We made it smaller. That's always the goal. x plus 2, it starts with a 2x cubed. So this must be 2x squared times 2 is 4x squared. It has a negative x squared, so minus 5x squared. Always a good idea to pause this and practice your long division on your own. Must be negative 5x, negative 10x. It's supposed to be negative 13, so minus 3 more, negative 3. Negative 6 is right, so we know we did it right. Now we have our original equation. Don't forget where we started. Was x plus 1. Now we got it to times x plus 2. And now I'm going to take our smaller, it gets smaller each time, polynomial and write it here. But now I'm down to a quadratic, and you can factor that on your own. So make an area diagram if that's how you know how to factor. Chances are that's how you know how to factor. And factor what's left. As soon as you get it down to x squared, you don't need to use p over q anymore. You can just use your factoring skills. So this has got to be 2x, let's see, minus 3 over here and plus 1. You can do an area diagram to double check me. So that's what our original function equaled. Was it called f of x? It was. So that was f of x in factored form. So now you know the factors. Question, calculate the roots. So make sure you understand when you're answering for roots, you should do x equals, and it's zero product property on every one. So the red one's going to give me negative 1. The teal one's going to give me negative 2. The first orange one's going to give me negative 1/2. Set up zero product property if you don't see where that came from. And the last one's going to give me 3. These are the roots of that polynomial. And if you plugged any of them into the equation, the original equation, you would get a remainder, an answer of 0. Okay, last one. If the note packet was already printed for you, you might notice this is different, so make sure you change the one on your note packet. I made it more realistic. This is something, the right size we would expect to see you do on test day. So start with your list of p over q's. Don't forget it's plus or minus. See if you can list those out. So factors of 6 over factors of 1. So how many choices are there? Remember, you have 8 choices because it's positive or negative. See if you can find one that works. See if you can do this problem on your own. Pause the video now if you don't want any hints. If you want a hint, save yourself a little time, but you won't have any hints on test day. Negative 1 works. So you can plug it in to see that it works. You would have been plugging everything in until you found one that works. Clearly equals 0. So once you know you have one that works, you're going to do long division with the factor. Remember, we just found a root, which is great. Now you know one of your answers. Negative 1 works, but as a factor, x plus 1, because you do zero product property and you get negative 1. Into my original polynomial. Starts with x cubed, so it must be x squared times 1. I need 6x squared, and right now I have 1, so 5x squared times 5x times 1. I need 11x squared, so 6 more times 6 plus 6. I got the right answer, so I know it works. So I am at x plus 1 times x squared plus 5x plus 6 would definitely give me that polynomial. But now I have a quadratic, so instead of doing p over q again, I'm just going to do normal factoring. It's up to you to practice your factoring. X plus 2 and x plus 3 would multiply to give me that. So this is my function. I'm just out of space, so I'm going to write it there. It's in factored form. So my roots, because it says calculate all the roots, are negative 1, zero product property, negative 2, and negative 3. Okay, hopefully that helps you with finding all the roots.